If this distribution is of the sample x1, x2 up to xn, where x can be 3, 4, 5, and on and on and on, find method of moment estimator for theta. Another way of understanding this is simply by saying find estimator for theta using method of moments, like that. But how do we do this? We need to find the expected value of the distribution that we have. But why are we doing this? If we recall, method of moments, let me just slide from here, m, and let me just lab that. So m about the origin is simply equal to the expected value of the kth term, like that, where k can be equal to 1, that is, k can start from 1 to all the way just like that. So if we recall this, that means we can compute the first moment, that is when k is equal to 1, the second moment of k2, and on and on and on. That's right. So this is simply the expected value, simply the mean. So the implication is if we're trying to estimate mu, my drawing is not too perfect, but hopefully you guys are able to draw better than this. So if we are estimating mu, in this case, let me just say theta. If we are estimating theta, we know that this theta is equal to the expected value. This means as well that it's equal to the first moment. So when we employ the method of expected value, finding the expected value, that means we are using the method of moments. So having this in mind, let's just go on and compute the expected value of the distribution that we have been given. Now the question is, how do we do this? So the first thing that we need to do is simply to remember the distribution that we are dealing with. And if we look closer at this, we would be able to tell that this is the negative binomial. So what is the formula for the expected value of the negative binomial? So we can simply say that this is equal to that. Actually, that's the formula for this negative binomial version. So when we have this, what is the second thing that we need to do? If you notice in our distribution that we have, we can't see clearly where k is as well as b. So to do this, obviously, we just need to rewrite the original form of this version of the negative binomial, which is just x minus 1, k minus 1. Then we have p to the power k. Then we have 1 minus p, x minus k. So doing the comparison of this and the one that we have up there, we can simply tell that p corresponds to theta. Then k corresponds to 3, like that. Then even from here, we can tell that k is 3, because this version of the binomial starts from x is equal to k. Then x can be k plus 1. Then we have k plus 2, and on and on and on. So even from this, we can tell that k is 3. So once we have this in mind, we can easily now compute the expected value, which is equal to the first moment, where k is just 3, as we have discussed, and p is just the theta. So having this, that means we've computed the expected value. But notice that we want to find the estimator for theta. So we can't leave our answer here. What we need to do from here is just to say this expected value is equal to x bar, the mean. So let me just create some space there. Let's say this time around, you can't remember the expected value of this form of binomial, this form of the negative binomial, sorry, or this version. So let's say you can't remember this formula, but what you can remember this time around is, let's say, the expected value of, say, y. So you can remember that the expected value is of that form. And we know that this expected value is of the binomial of the form I mean the negative binomial hold the form y plus k minus 1 of y there of b k 1 minus b y. And we know again that this version of the binomial and the one we have on top there, they are different. And the difference is this one has a probability of success. It speaks of success. And it shows us the number of trials that are required to get the kth success. While the other one here, we know that it speaks of failures. So this one shows us the number of failures obtained to get to the first kth success. So if I'm to cut from here all the way down there, we need to have another version of the negative binomial. In this case, it's this, the one that is showing us number of failures that we need, or may I say, that we have obtained to get to this kth success. So there's a difference between these two. So let's assume that this is what you can remember. But the question that you have been given is for you to find the expected value of this version of the binomial, which is different from what you have remembered. What can you do in this case? There is one important thing that we need to remember that can help us to compute this expected value by us just remembering this. And this important thing is simply remembering that if we write y equal to this term here, in the original form, that is simply saying y equal to x minus k, like that. If we write y equal to this, that means we can change this version of the binomial to this version here. And this is, if this is the case, that means we can have x equal to y plus k, like that. So if you want to get the expected value of x, you can simply say the expected value of x is equal to expected value of this term, like that. And this is simply same as saying expected value of the variable y plus expected value of k, the constant, which is just, we know this expected value is just k 1 minus b over p plus the expected value of the constant is just the constant, like that. So now we want to get this, so we should keep this in mind. So what we're going to do from here is, for simplicity, we will just do introduce a 1, multiply a k by 1. If we divide this term, it's nothing, they can go. But we want us to simplify our life so that we can get the expected value of x. So if we multiply there and we distribute the k here, we obtain this kp plus kp, this will be over p, and that over p, like that. So let me just create some space here. So this thing will simply be, let's have the common denominator there, which is p. Then we will have k minus kp, that is p into p, multiplied by that, it's just the term that we have there, and plus kp, like that. Then this term, notice that if we go, then what we will just remain with is the expected value of x that we have here, which is just k over p. So if we're able to remember this, we can simply solve for the expected value of x and work with that in there. Or the other thing that we said is that you are not able to remember the original form of this. Again, you are able to remember just this form of the binomial, like that, which is just y plus k minus 1, like that. Then you have y, you have k, p, then 1 minus k, we just slap there, minus k, and we have y. So if this is the form that you are able to remember as your original, then you find the expected value of k to be like that. Notice that again in this one, you simply consider this. Then you get your K. You do your comparison with that, which is just the same. K is 3, then P is theta. Then you compute your expected value just like that. What if? So that's it for this. But I was again assuming if you can't remember the formula for the expected value of this inversion as well as the other form of the version, you can just remember everything. What you can do is simply subscribe to my channel and check out my next uploads on how to derive the expected value of the negative binomial. Thank you for watching.